Welcome to this video guide on probability, designed as a practical survival guide for your notes. We will break down the essential concepts to help you master the basics. First, let's define our terms. An experiment is a repeatable procedure with a set of possible results. The sample space is the collection of all possible outcomes, while an event is a specific set of outcomes within that space. Calculating probability is straightforward. The probability of an event is the number of specific outcomes you want divided by the total number of possible outcomes. Remember, probability is always between 0 and 1. Let's look at a single event. When rolling a die, the sample space is 1 through 6. To find the probability of rolling an even number, we count the successful outcomes, which are 2, 4, and 6, giving us a probability of 1/2. Sometimes it is easier to use the NOT rule for complementary events. The probability of an event not occurring is simply 1 minus the probability of it occurring. This is a smart way to simplify your calculations. When dealing with two events and you see the word OR, think addition. You add the probabilities of the individual events together to find the probability that either one occurs. Conversely, when you see the word AND, think multiplication. You multiply the probabilities of the two events to find the likelihood of both occurring together, such as getting heads on a coin and a 5 on a die. Tree diagrams are a powerful tool to map out all possible events, especially when dealing with multiple actions. Multiply across the branches for combinations, and add down the columns if you are combining different paths. For independent events with replacement, the probability remains consistent. When Paul picks a ball and replaces it before picking another, the denominator remains the same for both events. When items are not replaced, the sample space changes. This makes the events dependent. Always watch out for the total shrinking, as your denominator will change for the second pick. Events are categorized as independent if they aren't affected by other outcomes, like coin tosses. They are dependent if past events, like removing cards from a deck, change the probability of the next outcome. Events are mutually exclusive if they cannot happen at the same time. If they can occur together, they are non-mutually exclusive. In those cases, remember to subtract the overlapping probability so you don't double count. Let's test your logic with a quick quiz. First, find the probability of a student traveling by bus or walking. Second, determine the probability of drawing 2 yellow pencils without replacement. To wrap up, keep these survival reminders. Probability is between 0 and 1, OR means add, AND means multiply, and always check if you need to shrink your denominator.